The first question asks what the probability is of getting a red card or a face card when choosing a single card from a deck. So you should think through that one if you haven't already. But anyhow, here we go. Here's a picture of the sample space. This is a picture representing a full deck of cards. Ace, 2, 3, 4 through 10, Jack, Queen, King, face cards being the Jack, Queen, and King. Hearts, diamonds, both of those are red, and then clubs and spades, both being black. So we want the probability of a red card or a face card. First thing that might occur to somebody is, well, just add the probability of getting a red card to the probability of getting a face card. Since either a red card or a face card will fulfill the conditions, let's just add them. Okay, well, let's put a question mark next to the equal sign and see if that works. Okay, well, it's very easy to see that there are 26 red cards and also that there are 12 face cards. If you know the deck, that's very easy to see. So that would add up to, well, the probability would be 26 out of 52 for a red, 12 out of 52 for a face card. If we add those, we're going to get 12 and 26 is 38, 38 out of 52, which comes out to 19 out of 26 if we reduce it. And of course, you get the decimal there, 0.7 something. Okay, now is that correct? Well, let's just check and see how many cards fulfill the condition of red or face. Let's see, this one, this one, this one, this one, this one, all these. Let's see, that's 13 cards are red, and then another 13 here. We count them. Okay, we're up to 26, and then we could count the black, the 3 face cards here and the 3 face cards here. Well, that's 26 and 3 and 3. If we're counting here, 26, 27, 28, 29, 30, 31, 32. So the probability has to be 32 out of 52. Now, why is it that we got 38 out of 52 here? Something is obviously wrong. Well, what's wrong is that these cards here got counted twice. And these are the cards that are both red cards and face cards. So when we count the red cards, when we count the 26 red cards, we're including these 6. And when we count the 12 face cards, we're including these 6. We can't count the same cards twice. All 6 of these cards got counted twice when we did this. To correct that, what do? Well, we can still add the number of red, or the probability of the red and the probability of the face cards, but we're going to have to subtract the probability of getting a card that's both. That way, it's only going to have, these cards will only have been counted once. Now here's a smaller picture of the situation. Think back to what you did in first semester liberal arts math with sets. Or if you didn't do first semester liberal arts math, you still would have done at some point sets with intersections and unions. Now usually we draw Venn diagrams of sets by drawing circles and overlaps and so forth. Here I'm going to draw rectangles just because that's the way the sets appear when we represent the deck of cards in this manner. So the red cards would be these, the face cards would be these, corresponding to this set and this set. And we see that we have an intersection of these two sets. So we have the cards that are red, the cards that are face cards, the cards that are red and face cards. The intersection of the reds with the face cards is this set, which we've seen contains 6 cards. Okay, and that's the set that we can't count twice. If we want to count the number here and here, if we want to count the number in the union of these two sets, we can do that by counting how many are in this set. That's a number of red. How many are in this set? That's a number of face cards, and subtracting the number of red and face because we can't count it twice. So we've got to subtract what was counted twice, and that gives us the result. Now, we go on here. I say there are only 26 plus 6 red or face cards. Well, we saw that when I counted them. So the number of red or face is going to be 32 out of 52. And if we use the idea of subtracting the overlap or the intersection of the two sets, we get the probability of a red card or a face card is a probability of a red, that would be in this set, plus the probability of a face, that would correspond to this set, minus the probability of having a card that's red and face, which would be these 6 cards. The probabilities would therefore be 26 out of 52 red for a red card, 12 out of 52 for a face card, minus 6 out of 52 for the cards that got counted twice. And we'll mention this, that the probability of red and face is 6 out of 52 because there are 6 cards that are both red and face cards, which you already knew, but since I wrote it down, I thought I'd better mention it.